In 1956, a geochemist by the name of Claire Cameron Patterson used a technique known as radiometric dating to determine the ages of several meteorites which had landed on Earth. The ages of these meteorites, on average, turned out to be approximately 4.55 billion years old, based on his calculations. The ages of these asteroids are the basis by which scientists have determined the age of the Earth itself, since they assume that they were formed at the same time as our planet. Geologists claim that they cannot obtain the age of the Earth directly by dating samples of rock, even rocks found in the lowest strata of the geologic column, because every layer of the geologic column has undergone mixing and contamination due to geologic processes such as hydrothermal circulation, plate tectonics, and weathering. When scientists refer to the contamination of these rocks, they're referring to elements which could either enter or leave the rock at any time since the rock's initial formation. The reason why elemental contamination is a concern is because of the process which scientists have been using to date samples, which is by radiometric dating. The way in which radiometric dating works is that some elements have unstable isotopes, which either gain or lose subatomic particles over time to become more stable. This process is known as radioactive decay. Unstable isotopes decay over long periods of time, transforming into either a more stable version of that element, or usually they transform into another element entirely. The 4 unstable isotopes that scientists use to determine the age of rock thought to be older than 50,000 years old are uranium, which decays into lead, potassium, which decays into argon, rubidium, which decays into strontium, and samarium, which decays into neodymium. The decay rates of each of these unstable isotopes is in the billions of years, so this method is thought to be great for calculating the age of very old samples. Scientists measure the decay rates of these elements by obtaining a sample size of a very large number of a single type of unstable isotope, and then they wait for some of those atoms to radioactively decay. They calculate the ratio of unstable to stable isotopes in a sample, and using the amount of time that it's been since all of the atoms in that sample were unstable isotopes, they calculate how long at that rate it would take for exactly half of the atoms in that sample to decay into stable isotopes. That amount of time that they calculate is known as a half-life. The half-life of the unstable isotopes is the measure by which scientists claim to be able to determine the age of materials that contain a large enough amount of unstable isotopes. This is actually the reason as to why scientists have difficulty using rocks to determine the age of the Earth. All rocks are subject to elemental contamination, which leads to inaccurate aging through radiometric dating. For example, argon is found in many igneous rocks. Argon is also the most abundant noble gas in the atmosphere, so it can easily contaminate samples. The issue with this is that one of the most prominent forms of radiometric dating is potassium to argon dating. This type of dating measures the ratio of potassium to argon atoms in a sample. When performing this type of radiometric dating, scientists assume that all of the argon atoms in a sample are present only due to the decay of potassium atoms, rather than the rock having any argon in it during the time of its formation, or due to argon in the air slowly seeping into the sample. If any of the argon atoms in the sample are not present due to the decay of potassium atoms, then it completely throws off the age that scientists obtain for that sample. Whenever scientists do detect anomalous levels of isotopes in a sample, they usually claim that it's due to technical errors rather than errors in their assumptions of the sample's original composition. Another issue which geologists have had with dating rocks is that they cannot directly date sedimentary rock, since they never contain any of the unstable isotopes required for radiometric dating. The method that they use instead to date sedimentary rock is to find out what strata of the geologic column they're from, and to then find out where any brackets of igneous rocks are around the sedimentary layer. The igneous brackets surrounding the sedimentary layers are then radiometrically dated. The calculated ages of the igneous brackets are then used to determine the approximate age of the rocks found in the sedimentary layers. This does not generally result in accurate findings, however, since the igneous brackets would most likely have been formed at a different time than the sedimentary deposits. and each layer of the sedimentary deposits supposedly were created at a different time. This method is the same way in which scientists determine the age of most fossils, since very old fossils, such as those of dinosaurs, cannot be aged using radiometric dating directly, for the same reasons as sedimentary rock. The only case in which radiometric dating can be performed directly on fossils is when the fossils are believed to be less than 50,000 years old. In that case, scientists can use another form of radiometric dating, known as radiocarbon dating, to determine the age of samples. There's a version of carbon which is an unstable isotope called carbon-14 that radioactively decays into another element entirely, nitrogen-14, through a process called beta decay. Carbon-14 has a half-life of 5,730 years, and the unstable isotopes are unable to survive for longer than approximately 50,000 years. Therefore, if a sample is older than 50,000 years old, there would be no more carbon-14 atoms left in it, as all of the carbon-14 atoms would have decayed into nitrogen atoms by that point. In order to determine the age of a specimen through radiocarbon dating, scientists simply observe the ratio of carbon-14 atoms to carbon-12 atoms in the sample. Carbon-12 is another version of carbon which, unlike carbon-14, is completely stable and never decays over time. Scientists assume that the ratio of carbon-14 to carbon-12 atoms in the sample was originally the same ratio as it is in living creatures nowadays, which is 1 carbon-14 atom to every 1.35 times 10 to the negative 12th power carbon-12 atoms. The unstable isotope of carbon, carbon-14, is formed from the interaction of the atmospheric element nitrogen-14 and cosmic rays, which alter the atomic structure of the nitrogen-14 atoms, turning them into carbon-14 atoms. Over time, these carbon-14 atoms, which were created from cosmic rays, decay back into nitrogen-14 atoms, which is their original state. Scientists assume that cosmic rays have interacted with atmospheric nitrogen-14 atoms at a constant rate throughout the entirety of Earth's history, and therefore, every organism that's ever existed would contain the same ratio of carbon-14 to carbon-12 in their bodies. Since radiocarbon dating can only be done on specimens thought to be less than 50,000 years old, scientists need to be concerned with the interaction between nitrogen-14 atoms and cosmic rays in the past 50,000 years. While it does seem likely that the carbon-14 to nitrogen-14 conversion process would not have changed much over the past several thousand years, this is likely not the case. Scientists have determined that the detonation of nuclear weapons in the open air has increased the levels of carbon-14 atoms present in the atmosphere. Inversely, the burning of fossil fuels, which is ramped up in the last century, has significantly reduced the ratio of carbon-14 atoms in the air. The type of molecule released in the atmosphere from the burning of fossil fuels is carbon-12 dioxide. These are carbon dioxide molecules which contain carbon-12 atoms. Keep in mind that carbon-12 is the stable version of carbon, which does not decay over time. According to climate.gov, as carbon-12 dioxide is released into the atmosphere from the burning of fossil fuels, this carbon-12 dioxide dilutes the ratio of carbon-14, which is the unstable isotope of carbon, as well as carbon-14 dioxide molecules which are in the atmosphere. Therefore, the ratio of carbon-14 to carbon-12 in the atmosphere, as well as in living organisms today, cannot be assumed to be the same as in the past. There has also been a flux in cosmic rays caused by Earth's magnetic field. According to NASA, the Earth's magnetic field shifts completely every 300,000 years, with the north and south poles flipping. Just 50,000 years is already 1/6 of 300,000 years, and therefore, the Earth's magnetic poles would have shifted 33%, or 60 degrees, in the past 50,000 years. This also points towards there being a change in atmospheric carbon-14 production, and indicates that organisms in the past would have been fossilized with different ratios of carbon-14 to carbon-12 atoms in their bodies. Radiocarbon dating is therefore not fully reliable, at least until scientists learn more about historic changes in carbon-14 production in the atmosphere, and other factors which may have influenced carbon-14 ratios. It's important to note that the reason why geologists assume that most rocks are millions or even billions of years old is because of the theory of uniformitarianism. In the mid-1700s, a geologist in Scotland named James Hutton had noticed that the geological features on the coast of Scotland looked like they had formed slowly over time. In order to fit his observations, Hutton created his own narrative that the Earth had actually been around for millions of years. Hutton relied purely on surface-level observations and did not have enough research or empirical evidence to actually prove his theory, yet he thought of his theory as factual. Up until this point, it was commonly believed that the Earth was only 6,000 to 10,000 years old, in accordance with creationism in the Bible. Another geologist in the mid-1800s named Charles Lyell had noticed that volcanoes grew slightly larger every time they erupted. From that observation, Lyell theorized that all geological processes had formed slowly over time, and that therefore the Earth would have to be millions or even billions of years old. Again, Lyell was only observing a single geological process and making assumptions about their connection to other processes. Regardless, Lyell's confirmation of Hutton's theory of the Earth's age helped to popularize the concept of uniformitarianism, and it was accepted eventually by society as the new paradigm. The theory of evolution was concluded in a very similar way to Hutton and Lyell's theory of the Earth's age. When Charles Darwin invented his theories about natural selection and evolution in 1835 during his visit to South America and the Galapagos Islands, very little of the fossil record had even been discovered. Darwin himself had excavated some fossils in South America, leading to his discovery of 4 different species of giant ground sloths that had existed in Punta Alta, Argentina, sometime in the past. Darwin had no way of dating the fossils to determine how long ago each species of giant ground sloth had existed, since scientists in the 1800s had not yet invented the process of radiometric dating or even determined the ages of the geologic columns. Therefore, it was impossible for Darwin to determine which species of ground sloth had come first, if any. His only clues were where he found each fossil, how deep each of the fossils had been buried, and their overall conditions. Living creatures provided Darwin with even more insight, since he could observe their bodies in a more pristine condition. His observation of the finches that lived on the Galapagos Islands led to his theory that species likely adapted to their environments over time by passing down beneficial genetic traits to their offspring, while organisms which had traits that were detrimental to their survival did not live long enough to pass their genetics down to offspring. This process is known as speciation. Darwin derived his own theory of evolution, which is a step further from speciation, from his observations of speciation alone, and well before scientists had made the discoveries of DNA, genomes, or cellular complexity. Darwin's creation of a theory that's still accepted by modern scientists is remarkable to say the least, since Darwin had no scientific qualifications of his own. It's questionable that Darwin came up with a theory of evolution without observing the process of genetic inheritance himself, aside from noticing that species with different traits existed. Even modern scientists have not yet discovered sufficient proof of evolution, aside from speciation. The 2 touted examples of what appear to be intermediate species in the fossil record are Archaeopteryx and Tiktaalik. Tiktaalik in particular is very poorly preserved, and therefore it's very difficult to observe its supposed transitional feet fins in detail. Since the theorized process of evolution requires such a long period of time, scientists have not been able to observe the process of evolution directly. The closest process to evolution that we can observe ourselves is the process of speciation. Every species of dog, no matter how genetically different, is still considered to be a dog, however. The reason as to why the Earth and its organisms have progressively developed new traits, while others have gone extinct, is largely due to changes in the Earth's climate. Modern scientists have created a theoretical timeline of the Earth, which portrays their current understandings of how our planet has changed in both climate and structure over time. These timelines are based on information such as their questionable radiometric dating techniques, as well as through their understanding of gradual geologic processes, such as the shifting of tectonic plates, and incomplete findings such as the current fossil record. It's been concluded by scientists that the first cyanobacteria to develop emerged around 3.5 billion years ago. Scientists use radiometric dating to determine the age of microbial reefs, known as stromatolites, in Western Australia, which scientists claim were created by cyanobacteria, and calculated them to be 3.5 billion years old, which the cyanobacteria would also have to be, if their calculations are correct. According to current scientific teachings, cyanobacteria are said to have initially respired anaerobically, but eventually evolved to respire through photosynthesis. Cyanobacteria are said to be the very first organisms to convert the abundant carbon in the atmosphere into oxygen through photosynthesis. As the levels of oxygen in the air began to increase, the Earth began to cool down, and it's believed to have entered an ice age state between 250 and 500 million years ago, which encompassed nearly the entire Earth. Once volcanic activity in the oceans began to increase, methane was released into the atmosphere, creating a greenhouse effect and warming the Earth back up, ending the Ice Age. Around 200 million years ago, according to scientists, the single large continent which existed at the time began to break apart due to an increase in tectonic activity. As land shifted towards the North and South poles, ice was able to form on the polar land, creating glaciers. It's assumed that 65 million years ago, the Chicxulub asteroid, which is estimated to have been about 6.2 miles wide, impacted the Earth at the Yucatan Peninsula. The strength of the impact resulted in a massive increase in volcanic activity worldwide. So much ash was released into the atmosphere that suffocated a large number of the dinosaurs and blocked UV rays from warming the Earth, making the entire world too cold for dinosaurs to continue living. The changes in the atmosphere, along with the shifting of the tectonic plates, are said to have resulted in large-scale climate change, and over the span of supposedly millions of years, would have contributed to another smaller ice age, which began around 2.58 million years ago, according to scientists. This ice age is known as the Quaternary Period, and the Earth is still in this particular ice age right now, due to the presence of at least one permanent ice sheet. Scientists assume that there have been several drastic and erratic fluctuations in temperature even within the current Quaternary Period. These fluctuations are said to have had a major impact on Earth's climate, and has hindered many organisms' chances at survival. Geologists estimate that between 12,900 and 11,600 years ago, an event known as the Younger Dryas period occurred, which resulted in a massive cooling of the northern hemisphere. Sea surface temperatures in eastern Canada were estimated to have been cooled down by as much as 18 degrees Fahrenheit during the Younger Dryas period. The major cooling event of the northern hemisphere resulted in the extinction of many species. It's still uncertain what caused such a massive cooling period, which lasted for approximately 1,000 years, according to current understanding of the event. One theory is that fragments of a large asteroid disintegrated in the atmosphere and struck Earth, resulting in what's known as an impact winter. Believers of the impact theory cite evidence such as the presence of magnetic microspherules, as well as nanodiamonds, around locations such as Lubbock Lake and Bull Creek, which would only have been formed from something like airbursts or impacts resulting from a fragmented comet. Another prominent theory is that the Laurentide ice sheet melted from rising temperatures as the Earth attempted to recover from the Ice Age, which in turn caused the neighboring Lake Agassiz to displace its fresh water into both the North Atlantic Ocean as well as the Arctic Ocean, which significantly hindered the North Atlantic conveyor, which moves the warm ocean water from the southern hemisphere to the north and keeps the northern hemisphere warm. Although this conveyor shutdown hypothesis is the more commonly accepted theory, it should be taken into consideration that the geochemist who initially proposed this theory, Wallace Broecker, eventually rejected his own original theory and accepted the impact theory as the initial cause of the Younger Dryas period. This complete uncertainty among scientists about an event that's so recent on their overall timescale of the Earth should be concerning to those who believe in the accuracy of modern science. The Earth is in the process of recovering from the Ice Age that it's been in for a very long time. Therefore, global warming should not be a surprise to the scientists that claim that Earth has gone through glacial and interglacial periods in the past. Scientists are concerned about global warming now because data shows that the Earth is warming at a more rapid rate than it usually would, due to a rise in carbon emission, amongst other causes. However, the Earth has warmed up significantly more in the past, which has increased the humidity in the air due to a rise in evaporation of the oceans, and has actually helped organisms on Earth to survive better. Plants are able to flourish far better in warmer and more humid environments. When plants are able to grow larger and reproduce more efficiently, and the environment actually supports the growth of seeds into new plants, more photosynthesis is able to occur on a global scale. More plants using photosynthesis results in more oxygen in the air. When there's more oxygen in the air, creatures that respire aerobically are able to grow stronger and larger, and they're also generally more intelligent because their brains receive more oxygen. Combining this increase in oxygen with an overabundance of plants to consume contributes greatly to animal and human life and reproduction. The more that animals and humans reproduce, the more CO2 there is in the atmosphere, which helps plants to respire, and in turn creates more oxygen for humans and animals. Global warming is really not as bad as everyone believes it is. For example, issues that the UN states global warming causes include droughts as well as a rising ocean. As the ice caps melt and the oceans rise, there's an increase in evaporation and precipitation, which leads to more frequent and severe storms, as well as floods, which contrast with the aforementioned droughts. When climate change scientists refer to both droughts and floods occurring simultaneously, they seem to be referring to the fact that some regions are more susceptible to droughts, such as Ethiopia, Somalia, and Djibouti, while other regions are more susceptible to flooding, such as Indonesia, India, China, and the southeastern portion of the United States. People still live in these regions right now, when severe droughts and flooding are already occurring. Therefore, global warming will likely not make these regions much worse to live in. Another concern about global warming is with rising sea levels. Scientists claim that if all the glaciers and ice caps were to melt, sea levels would rise a whopping 230 feet. As shocking and worrisome as this may sound, according to NASA, the sea levels are only projected to rise 5 meters by the year 2300 at the current rate of global warming. It is true that even 5 meters would submerge significant portions of currently exposed land if no action is taken. The type of action that needs to be taken should be reconsidered, though. Rather than attempting to prevent the inevitable warming of the Earth, which scientists report has happened many times in the past without human interference, we should instead be trying to either protect cities from flooding when the sea levels rise, or relocate cities entirely. It was a foolish mistake to build these cities along the coast at sea level, when it's obvious that sea levels are subject to change. So, although rising sea levels are a result of global warming and rising sea levels are going to occur again regardless of what humans do, simply based on the Earth's natural processes. What scientists are saying about climate change is not necessarily wrong, they're just blowing the consequences of global warming out of proportion. Scientific discoveries are always being made. New techniques of measuring samples and performing tests are always being created. When tests find results that researchers don't expect to find, they're often dismissed as technical errors. Scientists have been ignoring major contradictions in their own studies, such as accepting the Earth's age as 4.55 billion years old, because asteroids found were dated to be approximately 4.55 billion years old. Even the radiometric dating techniques that were used on those asteroids are questionable due to the possibility of elemental contaminants, not to mention that those tests were performed with outdated equipment back in 1956. Modern geologists, as well as past researchers such as Darwin, and the founders of geology, Hutton and Lyell, are making the unscientific mistake of over-relying on surface-level observations of modern Earth, and creating entire narratives about Earth's history and the nature of the universe based on those theories. If you doubt anything that I've stated in this video, do your own research. I'm confident that your findings will match what I've discovered regarding the various inconsistencies of not all but many scientific teachings, as well as the lack of sufficient empirical evidence to support the most promoted scientific theories, the over-reliance on surface-level observational theories, the blatant lack of proper precautions during experiments such as radiometric dating, and the questionable data that's often presented as entirely factual, which is taboo in our society to even doubt.